now let's take a look at question 2. So we are asked for the absolute minimum, absolute max and min of this function for x values in this interval if they exist. So I just named my function f of x, for convenience. And then as soon as a question asks about max and min, don't even think about it. Take a derivative. Set the derivative equal to 0 to get the critical points. And so once I did that, I got that I worked it down till cosine of x has to be plus or minus 1 over square root 2. And so cosine is always positive on this interval. And so really we only have to worry about plus 1 over square root 2. And that gives us these two possibilities. So to check the absolute extrema, either you could draw out a number line and then figure out the sign of the derivative, figure out where things are increasing and decreasing, or you could just plug in the endpoints and sort of check the endpoints and check the critical points. And I think it's actually quicker to do it by just plugging things in and checking, because if you do it the other way, you'll see that you have to kind of do it you have to check the endpoints anyway. So let's just plug in the critical point to begin with. So I started with negative pi over 4. And then when you plug it in, you get this value. And next I check the endpoints, okay? And of course, minus pi over 2 is not in the domain of that function. Remember, the function is 2x minus tan x. So it's not in the domain of the function, but we can understand the limit as x approaches that endpoint, and it should be plus infinity. So go ahead and check that. And then finally at the other endpoint, we just plug in and we get this value. And so comparing these three values, we see that there's an absolute min, right? And then this value, because the function blows up to infinity, there's no absolute max, although this one is in some sense a local max. And we're done.